Let's continue our conversation on quantitative research. Once researchers select the research design and collect research data, they normally move forward to data analysis and reporting. Let us focus primarily on data analysis. We conduct data analysis to answer the proposed research questions. First, we describe and summarize the data using descriptive statistics. Unless a study uses a purely descriptive design, researchers normally move forward to test hypotheses, identify relationships, or make predictions using inferential statistics. Finally, the statistical findings must be interpreted in relation to the research question. Descriptive statistics help researchers summarize and describe the main characteristics of a dataset or sample. Before conducting more advanced analyses, researchers need to understand who or what is included in the data and identify overall patterns in the variables. Descriptive statistics also organize and present data in ways that support preliminary interpretation. Researchers may use tables, graphs, percentages, averages, and measures of variability to make large amounts of information easier to understand, including for readers who are less familiar with statistical analysis. The appropriate descriptive statistics depend on the type of variable being examined. We will discuss this next. First, let us examine descriptive statistics for numerical data, which represent measurable quantities. Examples include age, test scores, and years of experience. Numerical data are commonly summarized using measures of central tendency and variability. The mean, median, and mode describe the center or typical value of a distribution. The mean is the arithmetic average. The median is the middle value when scores are arranged in order, and the mode is the most frequently occurring value. The range and standard deviation describe the variability or spread of the scores. The range is the difference between the highest and lowest values. A small standard deviation indicates that scores are closely clustered around the mean, whereas a large standard deviation indicates that the scores are more widely dispersed. Two groups of students' achievement scores are listed. Both groups have the same mean, median, and mode, suggesting similar typical achievement. However, Group B has a much larger range and standard deviation, indicating that its scores are more widely dispersed. Group A scores are more closely clustered around the mean. Next, let us examine descriptive statistics for categorical data. Categorical data describe membership in groups. Examples include grade level, course format, achievement category, gender, and race. Categorical variables are typically summarized using frequencies and percentages. A frequency indicates the number of participants or cases within each category under a categorical variable, while a percentage indicates the proportion of the total sample represented by that category. In this example, researchers report the frequency and percentages of each achievement category for a group of 10 students. Frequencies and percentages help researchers describe the composition of a sample and compare the relative sizes of different groups. We can visualize the results using a bar chart like the one you see on this slide. While descriptive statistics summarize observed data, inferential statistics use sample results to draw conclusions about a larger population. Researchers use inferential statistics to test hypotheses and answer research questions. Different statistical techniques are available for different types of research questions. This slide summarizes several commonly used entry-level statistical tests. Selecting an appropriate test requires careful consideration of the characteristics of the key variables in each research question. For example, an independent samples t-test is used to compare the mean scores of two independent groups. When a study compares the means of more than two independent groups, analysis of variance or ANOVA is appropriate. Effective quantitative analysis involves more than using statistical software to generate output. It is a sequence of justified decisions guided by the research purpose and research questions. Researchers begin by reviewing the research questions and identifying the key variables and their characteristics. They then use descriptive statistics to examine the sample, summarize the variables, and identify initial patterns in the data. Next, researchers develop statistical hypotheses and select an appropriate inferential test based on the research design and variable types. They conduct the analysis using statistical software and use the results to determine whether to reject or fail to reject the null hypothesis. Finally, researchers interpret the findings in relation to the research questions and study context. In this course, you are not required to conduct statistical tests yourself. Please focus on the conceptual understanding of these steps. We begin by reviewing the research question. Do students in two course formats differ in their average achievement scores? This question identifies two key variables. Course format is a categorical variable with two independent groups in person and online, while achievement score is a numerical outcome variable. Next, we use descriptive statistics to summarize achievement scores within each course format. Students in the in-person group had a mean score of 84.00 compared with 74.00 for students in the online group. Descriptively, the in-person group scored 10 points higher on average. The standard deviations provide information about variation within each group. The online group had a larger standard deviation 6.90 compared with 4.08, suggesting that online student scores were more widely dispersed. In contrast, scores in the in-person group were more closely clustered around the group mean. These descriptive results identify an observed difference between the groups, but they do not tell us whether the difference is statistically significant or likely to extend beyond this sample. An inferential statistical test is needed. Pause briefly to identify the appropriate test. The answer is an independent samples t-test. The hypothesis describes the possible relationship between course format and the students' average achievement scores at the population level. The null hypothesis states that students in the two course formats have the same mean achievement score. The alternative hypothesis states that the two course formats have different mean achievement scores. The statistical analysis will determine whether we reject the null hypothesis. We will continue on the next slide. After conducting the independent samples t-test using statistical software, we compare the p-value with the selected significance level, which is typically 0.05. The p-value represents the probability of obtaining a difference at least as large as the observed difference if the null hypothesis were true. If the p-value is less than 0.5, we reject the null hypothesis. Otherwise, we cannot reject the null hypothesis. In this example, the test produced a t-value of 3.95 and a p-value of 0.01 because 0.01 is smaller than the result is statistically significant, and we reject the null hypothesis that the two course formats have the same population mean. We can conclude that students in the in-person course scored significantly higher than students in the online course. High-quality data analysis should begin with trustworthy instruments. Instrument quality should be carefully considered in a study. Reliability refers to whether an instrument produces consistent results. Validity refers to whether the instrument measures the intended concept. As you review research articles, begin noticing whether researchers report information about measurement quality. We rely on statistical software to conduct data analysis. Here are several options for your consideration. IBM SPSS Statistics is a beginner-friendly manual-based program for managing data and conducting common statistical analysis. SPSS is not generally free, but UTA students can download it at no cost through the UTA website. R is a free, code-based statistical computing program known for flexibility, advanced analysis, and data visualization. It may be less user-friendly for beginners. JASP is a free point-and-click program designed for ease of use. Microsoft Excel is another option for organizing data, performing basic calculations, and creating charts. I personally like using Excel to create charts. Researchers may use different software for different analytical purposes. Learning more than one program can be useful in practice. Let us pause and consider this question. Do researchers have to collect data themselves in empirical research? When you are ready, move to the next slide for the answer. The answer is no. Researchers can conduct secondary data analysis without collecting the data themselves. Primary data are collected directly by researchers to address a specific research question. Secondary data come from existing sources originally collected by other researchers, organizations, or government agencies. Here are several commonly used secondary data resources for educational research. At this stage, it is sufficient to become familiar with the availability of these resources. Different datasets are designed for different research purposes and may include a wide range of variables. Appropriate use of secondary data typically requires additional coursework or training in dataset selection, data management, and analysis. Whether researchers use primary or secondary data preparation is necessary before analysis. This process may involve examining target variables, handling missing data, identifying outliers, and recoding variables. Without appropriate preparation, analytical results may be misleading. After we finish data analysis, it's time to write up the research paper. We have reviewed the key elements of a research paper several times since week 1. As we complete Module 4, I hope these elements are becoming clearer and more concrete. Given the focus of this course, we will not examine the discussion section in detail. The final goal of this course is to develop your ability to evaluate the quality of an empirical research paper. We will begin practicing this skill this week. After learning the key elements of a research paper, you should be able to critique a study by examining the relevant components introduced on the previous slide. You will have an opportunity to apply this criteria when reviewing a research article. Although reviewers may not explicitly describe every concern in terms of reliability or validity, these concepts are reflected in judgments about the consistency, credibility, and accuracy of the study's findings. Please review these supplemental readings to learn more about how reliability and validity are applied in different contexts. The first chapter discusses reliability and validity as indicators of research instrument quality. The second chapter focuses on how reliability and validity are used to evaluate the overall quality of a research paper. This week, we finished our discussion of quantitative research. Next week, we will begin exploring qualitative research.